So hi guys, this is Raghav with the second tutorial. So before I thought I would continue problems on change of order of integration of the double integrals, I thought I would do two problems on how to find the area of a double integral over a specified region. Okay, so if you can see here, I have written a problem for you here. It says find the area of the integral xy into x plus y dy dx between the curves y is equal to x square and y is equal to x. Now, as you already know, y is equal to x square is a parabola. Now, parabola is that conic where the distance between a fixed point and the fixed line is equal. The fixed point we call it as focus and the fixed line we call it as directrix, and the ratio we call it as eccentricity, which you have already studied in your 11th standard. Now, y is equal to x is a line passing through x-axis. Sorry, passing through origin. Now, first let me plot these two graphs. Y is equal to x square and y is equal to x. So if I equate these two curves, I get my points as 0, 1. So if this point is 1, 0. This is the line passing through y is equal to x. So this is 1, 1. So this point is 0, 1. So basically the whole point is I need to find this area now. So to find this area, look at the question. He has given it as dy dx. So first I need to find the limits for y and then I need to find the limits for x. So when I integrate first with respect to dy, I treat x as a constant. So now look at this. This is what we have done in the problems on change of order of integration also. Draw a line between in the specified region parallel to y-axis. So what is this point? Y is equal to x square. What is this point? Y is equal to x. So the limits for y is equal to x square into y is equal to x. Now, what is this region for x? At this point x is equal to 0 and at this point x is equal to 1. So now I integrate first with respect to y and then I integrate later with respect to x. So when I integrate with respect to y, we have x into x is x square. So therefore integration of y is y square by 2, xy into y. So x into y square, integration of y square is y cube by 3. Now apply your limits and simplify, you get everything in terms of x. Then you integrate with respect to x. We have already done problems on this in double and triple integration and you get your final answer. See, look at this case here. 3 by 56 is what I am writing here. Now 3 by 56 is a very small part. It is just 3 parts out of 56 parts. But look at this area also. This area is also very small. So the whole point is you need to find that area by plotting the graph. Then if you are integrating with respect to dy, you draw a line parallel to y-axis and then you get your y limits. Then you take the endpoints of that region and you take the limits for x. So this is how you do it. So now let me take you another problem where I take the region between the ellipse and the straight line. So we have a question something like this. So see, I am not bothered about the integration part here. I know you people are more than capable of doing that. My whole point is when they give you a verbal problem, how exactly are you going to find the limits? So now there is a curve which is represented by xy and he is asking you to find the area between an ellipse and a line. So as you know, ellipse always has an eccentricity what? Less than 1. So when I plot an ellipse, we know that this point is what? A, 0 and this point is what? Now x by a plus y by b is equal to 1 is the intercept form of a straight line where x-intercept is a and y-intercept is b. So the whole point is I need to find this area now. Now he says dx and dy here. So that means first draw a line parallel to x-axis. What is x at this point and what is x at this point? Now what is y? At this point y is 0 and this point y is b. So we can clearly write the limits for y as 0 to b. So what is x here? What is the equation of this line? X by a plus y by b is equal to 1. So x from this will automatically 1 minus y by b, a into 1 minus y by b. So you take an LCM a into this y. What is x here? This point is on the ellipse. So x square by a square is equal to 1 minus y square by b square. So x is equal to a into b square minus y square by b, because you have x square, so this will, so x will be a by b into b minus y, and this will be a by b into b square minus y square. Now, what if the same question was given as xy dy dx? Will I still get the same answer? I will, because this is definite integrals, it's not going to change. Now, at that point of time, take something like this, because you are having with respect to dy. What is y here and what is x here? If x is this, automatically, common sense, y will be this. And if x is this, automatically y will be this. So at that point of time, my limits for x will be equal to 0 to x is equal to a. So x is equal to 0 to x is equal to a. Y is equal to b by a into a minus x. Y is equal to b by a into root of a square minus x square. So you either solve this one or you either solve this one. You are going to get the same answer. So now because the limits are a little bit complicated, I am going to explain how to solve this problem. So that will be a revision of the double and triple integrals also. At the same time, see in this problem, you can learn double and triple integration, how to solve, because if you are able to do double, you will be able to do triple. How to get the limits from the given curves, at the same time how to do change of order of integration. So please understand this carefully. I will be doing it so that you can take care of it. So now just let me take this. So you are integrating first with respect to dx. So treat y as a constant. So y into x square by 2. What is my limits? A by b into b minus y. A by b into root of b square minus y square dy. So that is integration of 0 to b, y by 2, x square. So a by b into root of b square minus y square whole square minus a by b into b minus y whole square into dy. Now a square by b square and 2 will come outside. So a square by 2b square, integration of 0 to b. Now square and root will get cancelled, so it is b square minus y square. Now expand b minus y whole square. So b square plus y square minus 2by. So into dy. So I get a square by 2b square. So when you expand this, you get b square and b square will cancel. Minus y square, you have y here. Minus y square will become minus 2y square. Minus 2y square into y square is minus 2y cube. Minus into minus is plus. So 2by square, integration of 0 to b dy. So now it's a single integral which is very simple. So 2b into y cube by 3, 0 to b, y to the power 4 by 4, 0 to 3 dy. So I get a square by 2b square. So I get 2 by 3 b power 4 minus y power 4 by 4. So 2b power 4 by 4. So take out 2b power 4 common. So you get 2b power 4 into a square by 2b square into 1 by 3 minus 1 by 4. So b square will get cancelled. 2 and 2 will get cancelled. A square, b square. The LCM of this is 12. So what is my answer I am getting? A square, b square by 12. Now even if you take in terms of xy dy dx, you are still going to get the same answer. Here y will be from b by a into a minus x, b by a into root of a square minus x square. X will be from 0 to x will be from a. So still you are going to get the same answer. Here first you integrate with respect to y and then you integrate with respect to x. So in case they give you this question and even ask you to do change of order of integration, you just plot the graphs. So that is first you plot an ellipse, then you plot a line. If it is dx, first you draw a line perpendicular parallel to x-axis. If it is dy, first you draw a line parallel to y-axis. So this is how we are going to solve problems in evaluation of double integrals over a specified region. Now I am going to take two problems. I am just going to explain how to get the limits. The integration part you will be able to do. Now just take a question something like this. Okay? Integration of xy dy dx between x and y axis and x plus y is equal to 1. So x and y axis is the coordinate axis, x plus y is equal to 1 is this line. So this is my region. So here it says dy dx. So first draw a line perpendicular to y axis. So what is this y at this point? 0. Now what is y here? 1 minus x, because y at this point is 1 minus x. So y is equal to 0 to y is equal to 1 minus x. Now what are my x limits? What is x at this point? 0, and what is x at this point? 1. So x will be equal to 0 to x will be equal to 1. Now the same question, if you take xy dx dy, so draw a line perpendicular to x axis. X is equal to 0 to x is equal to 1 minus y. So x is equal to 0 to x is equal to 1 minus y. And here y is equal to 0 to y is equal to 1. Now you yourself can evaluate the limits and get the required answer. Now another question, just take an ellipse. Integration of y dx dy in the ellipse in the first quadrant. So I am just explaining you the concept so that you can understand. And if you take this, okay, this is my area. So here it says dx dy. So draw a line perpendicular to parallel to x axis. At this point x is 0. What is x at this point? X will be, just simplify, x will be a by b into root of b square minus y square. We have already done a problem. So what will be y? At this point y will be 0, and at this point y will be 0. Y will be b, because this is 0 comma b and this is 0 comma a. So if with respect to x, x is 0, so x is a by b into root of b square minus y square. Y is 0 to y is equal to b. So if the same question was y dy dx, draw a line like this. Y is equal to 0. What will be y? If x is this, y will be b by a into root of a square minus x square. So y is equal to this, and x is equal to 0 to x is equal to a. So this is how you evaluate double integrals over a specified region by finding the area. See, the whole point when they give you the problem is you should know how to plot the graph. If it is with respect to dx, if the inner integral with respect to dx, draw a line parallel to x axis. If the inner integral is with respect to dy, draw a line parallel to y axis. So yesterday I have done problems on this thing, change of order of integration. Now today I have explained you two problems and another two problems where I am 100% sure that you will be able to solve these integrals, because we have even done problems on triple integration also. So integrate all your thoughts. Don't differentiate yourself from the others thinking that integration is difficult. Work on these parts, because when you go into your third and fourth sem, integration plays a very major part. So please go through this tutorial, pause it wherever it is required to go understand how to exactly solve this verbal problem, which was a big pain for us when we were in our school days. Whenever the teacher said in the maths class verbal problems, we always used to say, verbal problem. So let us start facing our fears and solve these problems, and I come back with the video tutorial where I again do problems on change of order of integration. So keep smiling, work hard. As you know, there is no shortcut for success and there is no substitute for hard work. Keep working hard and let us achieve our dream. Thank you.